Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 13.4, Problem 1. This is Section 13.4, Problem number 1. It says, draw the graph of the following function. Be sure to label the x and y coordinates of any critical points. So we want to graph the function f of x equals 6x squared plus 3. And it's a 7-step process to get the graph. So step 1 is take the first derivative. So I'm going to go f prime of x equals 12x to the first. Now again, for that, what happens is the exponent of 2 comes down times the number in front of 6. So 2 times 6 is my 12. X to 1 less power, the second power drops down to a first power. The 3 has no x with it, so its derivative is 0. So that's step 1. I have the first derivative. Step 2, set it equal to 0. Step 3, solve for x. If I divide out the 12. X is 0. Step 4, take the answer from step 3, x is 0, plug it back into the original function, not the f prime, the f of x, and find the y that goes with it. So f of 0 equals 6 times 0 squared plus 3. And that's going to give me a 3. 0 squared is 0 times the 6 in front. I have 0 plus 3. I get an answer of 3. So this is telling me that I have a critical point at 0, 3. 0 for the x value, 3 for the y value. So step 5 is plot that point on a graph. And I have a graph ready to go here. So I have a critical point over 0 up 3. So I have a horizontal tangent line at that point. Step 5 is determine if my horizontal tangent line is there for a minimum or if it's there for a maximum. So what we're going to do is plug in an x value on either side of my critical point and see if the height is a little above or a little below the critical point that we have. So let's see what we get when we put in f of 1. And again, into f of x, not f prime. So f of 1 goes into f of x. Here, I'm going to have 6 times 1 squared plus 3. So 1 squared is 1 times the 6 in front. 1 times 6 is 6. Plus 3 more is 9. So if I put in a 1, I get out a 9. So if I go over 1, up 9, that's the point on my graph. And let's try an x value on the other side of my critical point. So my critical point was at 0. I'm going to go back to minus 1 and plug that into f of x. So f of negative 1 is 6 times x squared becomes 6 times negative 1 squared plus 3. So negative 1 squared is negative 1 times negative 1, which gives me a positive 1, times the 6 in front. 6 times 1 is 6, plus 3 more. That also gives me a 9. So if I go back 1, I also go up 9. And that's telling me that my critical point here with my horizontal tangent line is a minimum. So step 7 is to connect the dots. So it comes down, flattens out, goes back up through the other dot, and it will continue in that direction forever on either side.